Alright, now it's time for reflection examples. So these guys, similar to the ones we did yesterday, but now we got a different transformation. Reflection. Now with these graphs, when it says graph the image, it might be easiest to just do a flip, and I'll show you how that works. Remember yesterday we talked about a line of reflection? So we're going to identify the line of reflection. We're going to reflect this triangle over the x-axis. You'll notice the x-axis has a little x by it, and it moves left and right. So this is my x-axis, okay? That's my line of reflection. What does that mean? That means my points all have to be the same distance from that line. So, from my line of reflection, if I go down 2 to get to V, I'm going to do the opposite. Up 2 to get to V prime. Okay? If I go down 2 from the line of reflection, I'm going to go up 2 to get to U. You'll notice I'm only going straight up and straight down. I'm not moving left, right at all here. Okay? I'm only moving just right across that line of reflection. So for this guy, I'd go, oh man, from my line of reflection, 1, 2, 3, 4, 5, 6, 9 down. Again, we're right on this grid line. 9 down becomes 9 up. Bop, there you go, W prime. And we are done. Okay. Is that the only way to do it? No. But I feel like with the graphs, that's a pretty smooth way to do your reflections. Okay. I am going to show you the second method, but again, graphing, I feel like counting is the quickest, most efficient way to do the problem. What about a reflection across the y? Well, y goes up and down. So here's our line of reflection. And we're going to flip this picture, this rectangle across that axis, across that line of reflection. So instead of going up, down though, we're going to go left, right. So we count 1, 2, 3 left. We're going to jump it over here. 1, 2, 3 right. There's my new R. Q. 1, 2, 3 left from the line of reflection. Hop back to there. 1, 2, 3 right. Make sure you always count from the line of reflection. Don't go 1, 2, 3, 1, 2, 3. Oh, I'm right here. No, no, no. If you're 3 from this line of reflection, you gotta be 3 the other direction. Okay? And then we have our S. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 8. Yes. Now, shortcut. You know this makes a box. You could count P, or you could say, you know what, I know S is only 2 units above P. I know P has to be right here. You could do that as well. Bop, there you go. Okay. So with graphing, my opinion is it's easiest to count your shapes, or count your distance from the line of reflection. But what if we're working with just coordinates? This is going to be kind of like your second IXL assignment. By kind of, I mean exactly. And it says write the coordinates with the vertices after a reflection across the x-axis. So technically, you could just be like, all right, well, if these are our coordinates, I'm going to flip it and then get the new coordinates. You could do that, but remember, we can't really write on our computer screens, so that's where this problem becomes a little different. And if we look at yesterday's notes, we're going to identify which kind of reflection are we playing with. Reflecting across the x-axis. So A, negative B. So AB becomes A, negative B. What does that mean? It means our first coordinate, the A, stays the same, and the Y coordinate, the B, is going to change signs. So, we're going to keep our X the same. I'm just going to write my rule right here. Okay, so that's my rule. And now we just apply that rule to all these points. To be honest, we don't even need this graph. So that's going to be 1, and then change the sign. Because negative 7 would become a positive 7. Keep the X the same. change the y, keep the x the same. Oh, how do I change the 0? We just leave it 0. Okay, you can't have a negative 0, so if you have a 0 that you're going to try and change the positive to a negative, it's just not going to work. And what you've done here, what you're doing is you're flipping this guy 1, 7. You're flipping this guy over the x-axis, so this is your ending shape. Okay, and that is correct. Now, one problem you might see, and these ones I tried to exclude from your assignment because they're very different and they're tricky on a computer screen, because in my opinion you need a piece of paper. And the reason why you need a piece of paper is because the line of reflection is not on an axis, so we don't have a fun rule. Okay? If you do see one of these, this is how you do it. You draw the line of reflection. So you do have to know how to graph y equals -1. Y equals a number. You're going to go to that value on your y-axis and go left, right. If it was x equals a number, you'd go to that number on your x-axis, then go up, down. Okay? Once you get your line of reflection, you're now going to do the counting method. So 1, 2, 3, 4, 5, 6, 7, 8 from line of reflection. 1, 2. You'll notice I don't care about the x-axis right here. I'm only caring about my line of reflection. Okay? And my line of reflection is a unique one. It's across a little graph. L. Oh, I almost made a mistake because I counted from here instead of here. So from here, 1, 2, 3, 4, 5, 6, 9. For my line of reflection. There's my L prime. I know J has to be 2 spots closer to the line of reflection than L, so I don't have to really graph that if I don't want to. And then my M, I know it's going to be right across from my K along that same line. Okay, so I know it's going to be right across from my K because of that initial picture. That's my M prime. Now, are you going to see these on your problems? I hope not. But if you do, this is how you do it. Okay, and then you just get the points. So J, new point. Now this is where the x and y matters again. So we didn't care about it when we did our graph, but now that we're finding the coordinates, now we care about it. So J becomes 1, 2, 3, 4, 5. So that stays the same. But then the 6, 1, 2, 3, 4, 5, 6, 7, 8. -8. There's got to be some formula or something we could use here. I just don't know what. 6. 6. L would be 5, -10. And then M is -3 and -9. Again, will you see these? I hope not. But if you do, you're going to want to graph it first and then find the coordinates. Again, I did try to shrink your IXL assignment. I think you're only going up to a SMART score of 30 on this one. So again, hopefully you don't see these type of problems because they are quite different and they're tricky to do on a computer screen. All right, thanks for watching and have a good day. Let me know if you have questions.